Hey folks, and welcome to the latest video in the SAM for IBM Rhapsody series. I'm Andy Lapping, and in this video we'll use SAM to perform a safety analysis. Here we have one of the sample models shipped with Rhapsody, which hasn't really been modified in a few years now. Let's open our AI assistant, Claude. Now, as I've mentioned before, we can use any AI that supports MCP, and we can use their desktop clients or web clients. Today, I'll use the Claude web client, and as I'm using Rhapsody 10, I can open that inside the Rhapsody UI. Now, let's select this dishwasher class so we can focus the AI on a specific part of the model, and then let's prompt Claude to check it, starting with the operations. So perform a safety analysis on the operations of the selected class. Okay, so Claude found some high priority issues in those operations, some classic null pointer problems, and some issues with values going negative. Then we have some medium priority ones, and lastly some design observations. Now, it also noted the two primary concerns, null pointer access and timer underflow potential. Now, we could of course have SAM fix all of them right now, but instead let's work a bit more interactively. Let's start with show me the timer underflow issue. So there are the three operations that exhibit the problem and their implementations. Now, it's also noted that these operations are used in guard conditions on the state machine. Let's take a look in the model, and we'll have SAM find it for us. So show me in the model. Now, it's opened the state chart, which just so happened to already be open, and it's also highlighted the wash operation. So let's look at its features view. Yep, that is an issue. Let's have SAM fix just that one. Now, of course, I could have asked it to fix all three. There we go. Okay, now let's dive a little deeper. Let's select that class again. And this time we'll have Claude examine the state behavior. So perform a safety analysis on the selected class state behavior. For each issue you identify, show me the specific event trace that causes it. Pay particular attention to the state chart hierarchy. Don't speculate about potential problems without fully tracing through the model first. And if you cannot trace a concrete problem through the model data, don't report it as an issue at all. As with all AI, the better the prompt, the better the result. That last part is pretty important because by default, an AI assistant will perform pattern matching, which could identify issues that aren't really issues at all, especially on complex state charts. For example, if it spots a null triggered transition like this one, it will flag that as an issue, when in fact it's not, as it's mitigated by a timeout. Forcing it to back up its claim with an event trace will help to ensure we get nearer to the real issues. Let's take a look at the issues that have been identified. Okay, issue 1, well, that's not really an issue at all. The motor does in fact stop when the door is opened. The only reason the AI brought it up, I think, is to highlight some secondary behavior with the history connector, which it thinks is intentional resume behavior, but it may be worth taking a look at it. Issue 2 is a bit more interesting. A quick analysis of that one indicates it is right. As a user, I can request a mode change in the middle of the wash cycle, but it doesn't actually change any of the timing, because that's done in the setup operation right at the start. That's not necessarily a safety issue, but definitely one we don't want in our design. Okay, there was a third issue, but let's skip that and instead ask, how would you fix issue 2? And there we have two recommendations. We can prevent that mode switch during the wash cycle, or we can call setup on mode transitions to recalculate the time values, which would also reset the progress, which sounds like a terrible idea. And it's asked me, do we want to implement option A? Well, yes, I do. And there it's added guards to those transitions so we can only switch modes when we are in the ready state. Now, AI is especially well suited to this kind of analysis because it can reason across complex, interconnected model elements as a whole, uncovering emergent risks, subtle failures, and cascading effects that are hard to spot when working manually. Well, that's it for this video. Over the course of the series, we'll explore the other use cases and capabilities of SAM for IBM Rhapsody. But for now, thanks for watching.